Okay, and we're live. Hi everyone, welcome to another VJUG Book Reading Club session. This time we're very happy to have with us Venkat Subramaniam, and with his book that we're going to talk about here on this session, um, Functional Programming in Java. So Venkat, can you please introduce yourself to our audience?
Sure. My name is Venkat Subramaniam, a programmer, author, just having fun talking to you all and enjoying this.
Awesome. And we also here, I have a colleague with me, which is Ivan. Ivan, can you please talk a little bit about you?
Yeah, hello everybody. My name is Ivan Ivanov and I work for SAP. I'm also one of the leads of the Bulgarian Java user group. And thanks, Roberto, for having me again in this virtual JUG session.
Man, this is also your session. Yeah, so I'm Roberto. I work for Tommy Tribe. They are very kind, giving me the time to be here doing these sessions for you guys. Mostly work with Java EE stuff, but also very interested on the topic that we have today, which is functional programming, and the book with Venkat. So before we move to the book, for the audience that's seeing us right now, please go to our website. You can post your questions there on the Virtual Judge channel, and I'm going to be very happy to relay them back to Venkat to answer your questions. So please join, and let's try to keep this interactive. Anyway, to start the discussion, I would like to ask Venkat, what was his main motivation to write his book?
Well, first of all, thank you for having me. I really appreciate it. Thanks for everyone who has joined. I remember clearly the day that I got motivated to write this book. It couldn't be any more clearer in my mind. I typically write books in about 2 weeks. So I give myself about 2 weeks in a year, usually the week of Thanksgiving, the week after. Nothing really happens in the US. And I close the door, my kind family slides food under the door. For about 2 weeks, they don't see me, and I just cram through and write books. And this was, I think, 2012, if my memory is serving me right. I've heard about Java, introducing lambdas, and in all fairness, I'll be honest about it, I was not excited at all. I said to myself, I don't really care. Why should I care about lambdas in Java? I've seen lambda expressions in every other language that I've used, and hey, I'll just take a look at it. So I was just going through the features, and I remember coming to looking at streams, and I saw how streams really handled lazy evaluation. And that was the defining moment. I said to myself, this is big. This is critical. This is important. Java did not introduce lambda expressions. It's a misconception when we think Java has introduced lambda expressions. Java has introduced the Stream API. And without the Stream API, I don't think any of these would be really interesting. In fact, when I wrote the book, one of the things I wrote in the book, and that was that lambda expressions are the gateway drug, streams are the real addiction. Well, I live in Colorado, and if you know about Colorado, about drugs in Colorado, not that I have any connotations or connections with that, but the point really is we all kind of get excited about lambda expressions, but the real addiction in Java really is streams, and streams is what really convinced me that this was very important for Java developers to learn from. Typically, I always say the reason to write a book really in my mind is you have a story to tell as an author, and you want to get that story out in front of your audience. I speak in a lot of conferences, and I bring stories to conferences. I share it with developers who can be there in person, but there's only so much we can reach in person as developers, and book gives a channel for reaching other developers. And for Java 8, the streams is the story that I really wanted to share with the developers, and that's the reason I wrote the book. Single point, single reason to write the book.
I understand. That's awesome, and I mean, I have to say that I'm very surprised. Well, not surprised, but in a way, saying that you need like 2 weeks to write this awesome book. I guess I will take like 2 years to write it. So props to you. Really good job. Anyway, Ivan, I guess you have some of the questions, so we can start the discussion. Do you mind asking your first one?
Yeah, before I start with my first question, the question I've prepared, I would like to again ask our audience to post questions on the IRC channel of Virtual Jug, and to mention that today we are looking at the first four chapters of Venkat's book, which are on lambda expressions, then on collections, and stream API collections, then on strings, comparators, and filters, and then designing with lambda expressions, which involves several design patterns, part of which are described in the Gang of 4 book. So my first question is about the lambda expressions per se. You mentioned in the introductory chapter that the functional way of programming has been around in other languages for decades. And I can add that the functional style, the lambda calculus, is there before even computers existed. So do you think that Java is late for the party of having lambdas as part of a language construct?
Java certainly is late to the party, but I'll tell you what, they came with the best desserts. So I'm actually quite happy that they are late to the party. And the reason I say that is, if you look at a lot of different languages, well, let's step back for a second. I want to separate this into two things. One is functional style of programming. And with functional style of programming, you are able to pass around lambdas to functions, higher order functions. You can do this in language like JavaScript. You can do this in languages like Ruby and Groovy and so many other languages. But all the ones I just mentioned do not right off the bag provide lazy evaluations. So if Java had, and that's one of the reasons I was not excited about lambda expressions to begin with, without knowing enough about Java 8 at the time, I was not excited because I said, if Java is going to do what every other of these languages like Ruby and Groovy did, why should I get excited? So yes, they came late to the party, but they just did not introduce lambda expressions. They introduced lazy evaluations, plus a plethora of functions in the JDK that make use of lambda expressions. So in a way, I would argue it's good that they came to the party late because they get to see what everybody else is doing, and they came to fill the gap. And I think overall it worked out really well.
Okay.
Awesome. Excuse me, Venkat, can you please explain to our audience, well, maybe we can discuss this a little later, but maybe our audience is not very familiar with what lazy evaluations mean on the Streams API, so maybe we can talk a little bit about that.
So if you really think about it, I'll just give a very quick introduction to what laziness would potentially mean, just to get a feel for it. Is it okay if I switch over to screen sharing?
Sure.
Okay.
Sure.
So let me go over to screen sharing here, and let me know if you see my screen.
Yes,
we do.
Okay. So just to quickly, think about it. If you were to, use a function, let's say, in this case, I'm going to say this function is going to be expensive to indicate that, let's say, it's an expensive operation. And then it's receiving a number, and I'm going to keep it extremely trivial. It's just returning the number. Well, in this case, if I were to say x equals to 4, and if I said x is greater than 5 and expensive of, let's say, 5 is greater than 4, and then I want to say do something, and doesn't matter what we do here. Well, clearly we can fully expect that expensive 5 will not be evaluated in this particular example. And the reason why expensive 5 will not be evaluated is, we all know this as, it's because of short circuiting. Because x is not greater than 5, it would never come to evaluate this part. So we are all comfortable with it. And this is true of every language, or almost every language we care about. But on the other hand, if I were to make this a temp, and if I say temp is equal to this, we all know in Java, even though temp is not used at all, expensive is going to be actually invoked. So this is actually an eager evaluation versus a few minutes ago when I had the expensive inside of the if, that's a lazy evaluation. It's not going to evaluate until it's actually needed. Well, if you look at language like Haskell, this code written in Haskell, using Haskell syntax, of course, would not execute expensive. It would actually postpone evaluating expensive to the point where it would not even evaluate because we never use the value of temp. And so Java is not lazy from the get-go, whereas languages like Haskell are extremely lazy in evaluating. They postpone until the very last responsible moment and evaluate the code only when absolutely the value is essential. Now the question here is, if I were to go back to this code a little bit and say, how could we potentially bring laziness into this picture? I'm going to put a little statement here called, just for our purpose to see it, and you can see that in this particular example, I'll just say else, and then output, we'll put another little dots here. We can see that it printed the dots, but it never called the function. But on the other hand, if I were to take this expensive out and put a temp like I did a minute ago, and I said in this case a temp is equal to that, well, we can see that it's actually being called, which is kind of sad. But one of the beauties is, with lambdas we can engage laziness. We can kind of start implementing it ourselves. So notice what I'm going to do here. I'm going to turn this into a supplier for a minute. And I'll say supplier of integer. A supplier is a functional interface. So in this case, I'm going to bring in import java.util.function.supplier. And in this case, I'm going to turn this into a lambda. So now you can see that in this case, we are not sending the result of expensive, but instead we are passing a lambda to temp. And of course, here I'll call the get on it. Well, in this case, of course, if I were to run the code just now, you can see that it still did not evaluate the expensive. It simply printed the result at the very end. But on the other hand, if I said, if x is greater than 1, you will notice that it is actually calling it. So in other words, with lambdas, we can engage a bit of laziness in our code much more easily. So here's a way to think about it. When you create a lambda expression, this is creating a lambda, but it's not evaluating a lambda. The evaluation of the lambda comes in only when you actually, exercise it. And as a result, you can gain laziness quite easily with lambda expressions. Well, this is what streams do from the get-go all the way through. So when you call a function using a stream API, the functions you pass to filter, the functions you pass to map, they don't actually evaluate. The lambdas don't evaluate. Those wait until you reach a terminal function, and that's when their evaluation actually gets triggered. And that is one of the benefits you get out of this, is that it waits until that time to trigger the evaluation. And the lambdas kind of give us a sense of how laziness can be attained. With the example I just showed you, you can see that by using a lambda, you get to decide when to activate the function that's hidden. That could be one little function, could be a large number of instructions, but you can be lazy about it. You got this code as a data on your hand, and then you come back to evaluate it at a time you want to. And so you get three options. You can do it now, you can do it later, or postpone it to the fact you never do it. And that is one of the biggest powers you get out of this.
Okay. Now
yeah, that's awesome. I mean, exactly. Yes, it was very well explained, and yes, our audience is very did really understand it properly. So we have our first question here from our RC. Actually, it's our friend Simon that's asking this question. So Simon, you can join us if you want on the Hangout. Anyway. Simon is asking if, Venkat, do you think that Java 8 has done a good enough job with lambdas in a way that developers will stop moving to Groovy and Scala, or is there more to do?
Simon is always trouble, and he's still trouble now. So here's my view of what Java has actually done. And some people think that Java 8 is a death blow to a lot of other languages on the JVM. And I strongly disagree with that kind of belief. The reason I say that is before Java 8, we had haves and have-nots. You had languages that supported functional style, and clearly Java 8 did not support. And as a developer, this was a huge gap. Either I had lambdas or I had no clue what lambdas are because I never got a taste out of it. And this was a huge gap that stopped a lot of us from even getting a taste of it, and leave alone adopting it. With the Java 8, we have now the ability to really experience lambdas, and once we do, then we get to choose. What I normally say is, take a language like Groovy or take a language like Scala. There were n things those languages provided that Java did not provide before. Now those languages provide n minus one things. That one thing now that they used to provide, Java also provides, which is lambda expressions. And as a result, I think we can see that people who want to gravitate towards those languages now have a smaller barrier to entry because they already know about lambdas really well. And then as a result, they can easily move over to those languages and enjoy these other benefits. The second thing is, if you look at Groovy, for example, in Groovy, you've had lambdas from the get-go. For a good 13 plus years, we have had Groovy's lambdas. But Groovy lambdas are not lazy evaluations. In Groovy, when you go through a function composition, you are going through transformation of one to the next collection. Well, the good news is today in Groovy, you can use the Groovy closures, but you can call into the streams from the Java API. I gave a talk in last year's Spring One conference where I showed how Groovy programmers can use Java 8 from Groovy code. And the reasons to do that is because you can get the best of both worlds. You can get the conciseness of Groovy along with the benefit that you get from using the Streams API in Java. So if at all anything, I would say Java 8 has made the other languages on the JVM more approachable. And with that said, I can get comfortable with Java 8, but I feel I need to use meta programming. In places where I feel I need more conciseness, in places where I feel I need to create a DSL, or in places where I want to do a much sensible and easier XML parsing, or maybe a better handling on concurrency, with those needs, I can mix and match these other languages with Java. So I think Java 8 really closes the gap, closes the barrier to entry than it was before. And I see this as being very positive for Java. I see it as being very positive for these other languages as well. That's the overall feeling that I have about this, and not one of pessimism or concern like a lot of other people do. So even though Simon is creating trouble usually, he usually has a good question as well.
Yeah, I understand, and I also agree with that. On the other side, he also mentions what else do you think that Java or even other languages might add to Lambda expressions? Do you feel that something's still missing? Maybe Java was waiting for other languages to, in a way, to see what they were doing to actually come up with, after so many years, with something that was really good to Java, instead of like coming up with something that was not going to really cut it out. What do you feel about it?
Well, in all fairness, I think there's definitely quite a few things we can point to and say Java should really have had this. However, if you really look at the schedule for Java and how much effort it took for them to come out with this, we can't expect any further delay in the release of Java at the time. And so given a choice between what they released versus delaying it further to release with more features, I clearly would argue that what they did is the right thing. Things I normally complain about are, I really wish there was a tuple API or a tuple class. I really wish there was either class like Scala provides an either. I really wish there was a way to deal with exceptions a lot better while working with Streams API, and there's no clear direction other than we formulating a few ideas as to how to deal with exceptions. These things are areas, and then would be really nice to have maybe more fluent functions like a zip function, maybe a function to do much better things like Haskell, like take while and skip while functions, some of which are being addressed in Java 9, but there's a slew of functions you can expect to see. But keep in mind though, there are other libraries that provide this. If you're using reactive programming, most of the reactive programming libraries provide these kinds of functions. So it's not, and again, these are not language level constructs. These are library level constructs in a lot of ways. And it's a question of whether you choose to use JDK library. I could be sitting here and complaining that it would be really nice to have tuples, but come on, how hard is it? I was working with a few people who said, hey, you know what? We've already gone and created these things for us. Clearly, we can agree that it would be nice to have these things in a standard library, but that doesn't stop us from moving forward. So in a way that I would argue, Java did the right thing as to provide the most essential parts in the language, and anything that's not provided is nice to have. It gives an opportunity for us to complain, from time to time, but it's not a showstopper. I think in a lot of ways, Java has provided what is absolutely essential for programmers to start using and building on top. So would I say that would be nice to have a few more things in the language and the library? Absolutely. But does that mean that we don't have enough to be productive and master the functional style of programming? I would say no. We already have everything we need as a essential set of tools to work with. So I think that's pretty positive in that regard.
Awesome. So we have a couple of other questions here from the audience. So some of anyway, here's a question from Herman. He's asking, do you think that functional programming makes debugging harder?
I don't spend my time writing bugs, so I don't know if I can answer how to debug. I'm just kidding. Well, so it's really a common question. I get asked this question almost every time I talk about Java and Lambdas. But let's step back for a minute before we answer that question. Now, let's say you are asking, I'm asking you, with Java 5, let's say, and I'm asking you, hey, is it really hard to debug Java? And you're going to say, oh, no, Venkat, it's really easy to debug Java. Just put a breakpoint in a function where you want, hit the button, and off you go to debug. And I'm going to say, I'm so glad, Alberto, you said that, because I got 1,300 threads running, and it's really a nightmare. And you're going to say, get out of here. So what makes debugging hard in Java 5 was not that we couldn't debug. It's the non-deterministic nature of multi-threading that really made debugging really hard. Well, now let's talk about lambda expressions. With lambda expressions, when you write a function, whether it's a lambda, because after all, a lambda is an anonymous function, so whether you write a lambda expression or a regular function, you can put a breakpoint in it and off you go. It's no different from debugging a regular Java program. But what gets us really is, again, to repeat myself, the lazy evaluation. So if you had a block of code where you're creating a stream and you're returning the stream to another location, if you put breakpoints within the lambda expressions or within functions being called from lambda expressions, and then you're waiting for that to hit, you're going to be disappointed, because it's going to hit them not when you have created that bulk of code to create the stream. It's going to get called when that code gets exercised by a terminal function, which may never happen, which may not happen for next several minutes. It may not happen in our library code. It may happen in elsewhere down the stream, or depending on the situation, it may get completely bypassed. And so this can be very frustrating. So in other words, if you want to debug Java 8 code, the first thing you need to worry about is not whether it's easy or hard to debug, the first thing we need to worry about is, do we really understand the semantics of lambda expressions? Because without understanding the semantics of lambda expressions, we cannot debug lambda expressions. We're going to be frustrated. We're going to be felt cheated. We're going to feel deceived by the code running like a wild bunny. But on the other hand, if we understand lazy evaluation, if we understand that lambdas being passed to intermediate functions are not going to be evaluated now, but only at the time when those get evaluated when a terminal function is called, then we are better prepared to debug. The second thing is, mix with that parallelization. This is opening a can of worms, because now you start putting breakpoints in lambdas, and you are turning your stream into a parallel stream. So on one hand, laziness will make things very hard for us to comprehend. On the other hand, parallelization can help things really hard for us to comprehend. But once we understand the nature of lambda expressions and evaluations of them, then we are better prepared in debugging. And that is the real key, is not that debugging is hard, it's that the semantics of, so the short answer is, when it comes to lambda expressions and streams, what you see is not what you get. What you get is something very different from what you see. So it's not the code you are looking at that matters. It's the code that you see behind it that really matters. And once you see what the code actually is going to do for you, you are better prepared to debug it properly. That's one thing. The second thing I would always also say is, I do a lot less debugging now than I did 20 years ago. Not because of any other reason than I do a lot more automated testing. So even when it comes to debugging, it's extremely narrowed down now. My debugging usually is in a failure of a test rather than trying to go on a witch hunt. I remember those embarrassing days when I would leave work with the debugger still blinking, only to come back the next morning and start over from the blinking debugger screen, trying desperately to find out what's going on. Thankfully, my development skills and my, more important, discipline has improved over the past few decades. I do a lot less of those nightmare debugging sessions now. And so mixing some of the disciplinary practices, mixing that with a better learning and understanding the semantics, would require a lot less debugging on our side, and a better handle on debugging the times when we do need to use it, I think.
Yeah, that's awesome. Anyway, have you come to any situation where you actually had to debug a stream or a lambda before?
There are a few situations. One of the places where it's not even at a runtime debugging, but one of the annoyances is lambdas do a fairly decent amount of type inference, except that type inference is great when it works, but it's really lousy when it doesn't. And those are desperate situations when you have to kind of step back into more modular code, and then you work yourselves back to writing lambdas. The other times when it gets a bit confusing is when you're trying to work with a collection and you're expecting a particular function to be called, and it's not quite calling that function or the lambda, and you're not quite sure why it's not calling it. So you kind of stare at it for a second, and then once again you try to reason through the code, and usually within a few seconds to a minute or so I regain. It's usually my understanding of the data structure I'm dealing with is different from the realities of what I'm dealing with. But I have to say that I've really not come across a situation where I've been totally lost and desperately trying to hack my way through. That's not happened, thankfully. And one of the reasons for that, I would argue, is two reasons. One is when you're dealing with an imperative style code, you normally deal with quite an amount of mutability. The more the mutability is, the more the errors that you have in code, because as humans, it's really hard for us to reason with the code when things keep changing. As a joke, I always ask a group of programmers, raise your hand if you juggle, and very few people will actually raise the hand. And then I would tell them, well, you're all lying, because you all juggle every single day. That's called programming, because we juggle this mutable state in our mind all the time, and we are really bad at it. Well, with functional programming done correctly, we do a lot fewer mutation, and as a result, the chances of errors is usually a lot less. The second is the code is more expressive and more concise and more easy to reason as well. The code begins to read more like the problem statement. I'm going to say that functional style reduces accidental complexity, whereas imperative style usually has more accidental complexity. So the reduced complexity also results in a fewer cases where I have to go on a witch hunt to find the bug. It's a lot more evident. So the few times that I get stumbled, I'm able to reason myself out of it fairly quickly. There's also other things I would also say are fairly important. One of the bad habits we have developed over the past several years is to give ridiculous variable names for variables. We all are, culprits. We all are doing that. Well, with lambdas, that's even more important. If we give ridiculous names to lambda expressions, it can be really confusing as to what type we are really dealing with, and that can result in certain issues as well, especially when multiple types have similar methods. We might end up calling a method we think we are calling, but it could be something else. And the answer to that is not to go back and put more type information, but to really give more meaningful variable names as well. I blogged about this a few weeks ago in my blog, where I encourage people to use more type inference, but compensate by giving good variable names. Because somebody tweeted and asked the question, is type inference really making lambdas hard to maintain, hard to understand, and that can lead into debugging issues as well. And my blog entry basically went off of this particular tweet, and I mentioned we really need to really create code that's easier to understand, easier to maintain, and so that is something to think about. We can ease the pain in a great way by doing some of these things.
Yeah, so actually, really something that Simon is asking here, which is actually very related with what we were discussing. Some people say that lambdas are overused and can make Java harder to read. And reducing verbosity also removes explicitity or detail. So I'm guessing that you're also familiar with JEP 286 type inference for local variables. What do you feel about it? What's your opinion? Do you agree with it?
Oh, no, not at all. And the reason I don't agree with it is, if I lack discipline and I need to have a certain structure around me for my lack of discipline, then the question really to ask is, what are we trying to protect? I program as much in dynamic type languages as I program in statically typed languages. And a few decades ago, I was scared to program in JavaScript. And I hated languages that were dynamically typed. But over the years, I've started programming in a reasonable number of dynamically typed languages. And I have to say that I actually enjoy having less ceremony and less structure around my code, with a bit of an increased discipline on my part. And so my argument is, if we can have a fairly good discipline, now, people would always say, well, but when you're working in a corporate environment, we cannot expect that kind of discipline. And again, I beg to differ. And the reason is, if we are hiring a bunch of kindergarteners and letting them run loose in the company, there is nothing that can help us. But if we consider ourselves to be professionals, then there is a bit of a responsibility we have. I'm not talking about the status quo. I'm not talking about how things are, but I'm talking about how things can be. And these are not things that are so beyond reach. I've seen this work effectively in several teams which are very passionate, very dedicated, very disciplined, and take upon themselves. And so by giving good variable names. I was recently working with a client who has been using Java 8, and I was doing Java 8 training for them, and they wanted to really bring their entire team through Java 8. So they thankfully had some Java 8 code already. So in the middle of the course, I was critiquing and I was saying, lambdas are glue code. I had a blog about it, and I brought up the blog and I showed them, and I said, lambdas are glue code. So if you Google for lambdas are glue code, you will hit the blog. and lambdas are glue code. And I was telling this, and as I was showing this blog in the class I was teaching and I was explaining things, I had people smile and make eye contact with each other. And then I finished that, and I had a lab for them to work on. And so as they were working on the lab, one of the guys, made a sign to me and said, "Come over." And I walked over, and he pulls up a code and he says, "This was written by a developer who's not here in the room." And he shows this one lambda, which was about 70 lines long, sitting inside a function, only to follow by another lambda, which is as long, to be followed by yet another lambda, which is as long or more. And so this function is a monster with multiple lambdas. He brings up code coverage and shows me, do you see in the code coverage, none of these lambdas are covered in our code coverage. And also he says they've been attacking several bugs within those lambda expressions. And then he said, "I'm so glad you talked about lambdas or glue code, because that's a discipline we totally lack in the company now, because we saw lambdas and we ran crazy towards it, and we totally disregarded some of these practices we should follow." And I think that is something we need to really ask ourselves when we look at a feature. And this happens to me in almost any language or tools I begin to learn. The first thing I ask is, how do I really adopt this in a way I don't go insane adopting this? One of my deficiencies, I'm a little guy. I'm not the smartest person in the world. I would say I'm the dumbest developer I ever have come across. And one of the things I fear the most is accidental complexity. So whenever you introduce me to something new, the first thing I would ask myself is, how do I benefit from this one without being dragged into violence and hardship that it can potentially bring? And I do this with almost every tool. And that's exactly what I asked myself when I looked at lambdas. And the first thing I told myself is, I'm never going to use a multi-line lambda expression. Putting a curly is a crime punishable under law, in my opinion, with lambda expressions. Lambdas are glue code. They are the landing. You want to be able to go from your call through the lambda into where real action happens. And so putting any bulky code in lambda should be something we all cringe. And once we develop these kinds of practices, then it becomes very manageable. Then we're not reaching out for things to compensate for our lack of discipline. So that is one thing I've been struggling really hard, is to myself and to others, is to say, let's think about how we can be more disciplined. Let's think about how we can create and use these tools so that these tools become more manageable. The life is built around by these things. We use tools. We use knives in the kitchen. We use cars to drive around city. But we can't fear about these things. These can be really dangerous if you're not careful. But with good discipline, we are extremely productive with these tools. Same thing comes to programming tools as well. We shouldn't let fear rule us. We should instead, bring good discipline and practices to help us really reap the benefits of these tools. I think that's very critical.
I see. That's awesome. I love that story about having a huge function with lambdas. I've seen a couple of those as well, and gets me really, really mad when I see them. So we have a couple of other questions here, and this is from Marie. He's mentioning functional programming approach for large-scale real-time systems.
So when to use functional programming for real-time systems is the question?
The question is mostly worried about performance for large-scale real-time systems. So he's pretty much asking about performance for using the functional programming style for this type of...
So I'll share with you a story. I'll share with you a story about performance. Anytime I hear about performance, I smile about it, because most of us fear about performance, and we don't really know what performance really means. I would argue, I don't want a system that performs the fastest. I want a system that performs adequately. That's something people cringe when they hear, but it really is so true to think about it, right? You know, it's like saying, I want the fastest car, and then you ask me, where are you going to drive it? I'm going to drive it in a crowded downtown. You're going to say, dude, take a bicycle. You don't need a car, actually. Actually, I'll tell you this. This was funny. I was on a cab ride from the train station yesterday, and I got into the cab, and as the cab started driving, there was a lady riding on a bicycle next to the cab, and I glanced out. I saw this lady, and you know, it kind of registered in my mind that there's somebody on the bike. I didn't pay attention to it, so we passed her. A few minutes, I was, you know, looking down to read something. A few minutes later, I look around, and I see the cab crossing a person on the bike. I looked at it. That person looks familiar, and I made a note. It was the same lady. In the 15-minute ride, we passed her 7 times because the traffic was so bad. The bicycle was faster than the car. So every few minutes we're passing her, only for her to pass us. And I thought this was really funny to see that the car was actually much slower than a bicycle. I think this makes a really good analogy to what we're talking about, right? So even though in theory a car is the fastest thing, on this road the bike was much better. And we tend to forget this quite often. So I'll give you an example of this. I have an application where I'm using lambda expressions. And I wrote this about, 4 years ago, and not obviously in Java, but in another language. And I wrote this about 4 years ago, and I completely disregarded performance. In all honesty, when I was writing it, my mind was like, oh my gosh, what would be the performance? What would be the performance? And I said, don't worry about it, Venkat. Ignore, ignore, ignore. And I got it completed. And how was the performance? No problem at all. Because I didn't have users. I did not have a large data set. So what would cause poor performance? So it worked really well. And about 2 years went by. I got an email from one of the customers who said, do you realize that every request is taking 15 seconds to respond? And I said, yeah, I've been looking at it for a few days now. I see what you're saying. Let me look at it. And every single request, period, was 15 seconds long. Why? Because in the 2 years, we've accumulated quite a bit of data that we are processing. And I spent 2 hours. And for the 2 hours, I looked at everything every programmer points to say this will give performance. I'm using functional style here. I'm transforming this function here. 2 hours later, I converted the code and did the profiling. And the code now took 15 seconds to run. And I felt like an idiot. And I'm like, wait a minute, why doesn't this perform after 2 hours of work? I hit on every single thing that I can think about as would be poor in performance. And then I got down and did profiling. And when I profiled it, I found out one function took the most of the time for this code to execute. I never even ever suspected that function. And what did that function do? It was making a command at the database level, and at the database level, the library was converting thousands and thousands of objects into IDs into objects. And the minute I realized it, I took a very bold step. I threw out every single change I made in the 2.5 hours. Completely gone, poof. Reverted back the code to what I had in the morning. Did a little bit of research. 15 minutes later, changed only that one function. The code took 33 milliseconds to run after that. And I learned my lesson the hard way. So my recommendation is, don't fear when you look at the code. Don't assume the code is going to be poor in performance. First, if the code is extremely hard to maintain, if I give you a ball of mud and I tell you to improve the performance, you're going to have a really hard time. But if I have a code that's easier to understand, easier to maintain, at least we have a better stab at looking where the performance problem is and improving it. So funnily, I usually say that we write really bad code 10% of the time in order to make the code better in performance. The other 90% of the time we write bad code just to be consistent with the other 10% of the code. So we really have no reason to do that. And this is a fear that we let rule us most of the time. And we really have to ask the question, is the performance adequate for what I have done after writing the code in an elegant way possible? If it's adequate, don't bother. If it's not adequate, then and only then, look at how to improve performance. The second thing I also want to say is, you can work really hard to improve the performance of sequential code by improving it a little bit. But if performance is really critical because you have a large data set, you probably want to consider using other opportunities like multi-threading, for example, a parallel stream, for instance. That can give you leaps and bounds of performance where it makes sense. But if you wrote the code in an imperative style to begin with, that opportunity is even more difficult to really attain. And so my argument is, don't let the fear rule about performance. Write the code in the most elegant way. See if the performance is adequate. If it is, leave it alone. If it's not, then and only then come back, profile the code, find where the performance issue really is, and then attack that and improve the performance, instead of just assuming that code every corner we turn is going to be poor in performance.
Awesome. I guess that you heard the phrase before, premature optimization is the root of all evils, right? What do you feel about that?
Yeah, absolutely. I completely agree. We don't even let so one of the problems we deal with as developers, and we see this constantly, is we are so eager to do local optimizations. We are so eager to say, turn left here, turn right here. But we fail to really take note of where in the world are we really going. I'm a huge fan of this mantra. It's called, make it work, make it better real soon. And I say this to myself over and over because I'm as much a flawed human being as anybody else is. When I sit down to write code, what does my mind say? Oh, do all these things. And I got to remind myself, Venkat, wake up. Make it work first, then make it better real soon. So to avoid that eagerness to optimize every corner we turn so that we can get a feel for something that works. And this is something I use this example. You probably heard this example before me saying, but I say this all the time because I learned this as a kid. When my dad used to show me how to put together stuff. We would fix a furniture in the house, for example, or we would do plumbing. So as a child, I had an opportunity to do these kinds of stuff with my dad. And one of the things he would teach me is, you never tighten things, either in the furniture or in a plumbing. You kind of get them all loose to begin with, and then once begin to fall in shape, and you then start tightening them one at a time. And this is a lesson I've carried with me. I was working with my son before I started this trip, and he was trying to do this exact premature optimization. Oh, tighten this, Daddy. It's like, no, sweetie, just wait for a minute. Let these things fit together. And I was telling how my dad taught him. It was like a very happy moment for me to teach him something that I've learned from my dad, is to say, don't be eager to make every step perfect. Let things begin to fall in place. Get a full view of things. Then start, tightening things together. Coding has a lot of those things we can carry from other areas. And that is one of the things, is not to really go with that premature optimization or local optimization. Let things begin to fall in place. Let's then go back and improve those things. I think it's something we can learn, definitely, and apply.
Hey, that's awesome. So we have a couple of other questions here. This next question is from, let me see, Site 2. Well, that's Site 2. I think this is the right name to pronounce it. And he's mentioning, could Java in a further version make streams parallelizable on the fly, as opposed to have developers having to specify them on the code? Or is that a bad idea?
Yes, I think it is something we got to be very careful about. So here's a problem. Parallelization is a tool. Let's ask this question. Should I take my car every time I leave, or is there a time I should decide whether to take my car, to take my bicycle, to walk on the foot? Let's say you have two kids at home, and you want a few spoons of sugar. So you yell out to the kids, hey, go to the neighbor, get some sugar. Well, there's one kid who's going to jump the fence. The other kid is going to go take a car to go to the neighbor. You know which of these two kids is going to get you the sugar really quickly? But on the other hand, if you want to go to the store, which is 10 kilometers away, and get milk, the kid who's going to jump fences is not going to go to the store and elsewhere. So in other words, we can't apply techniques, tools, parallelization being one of them, without the context of two things. A, is the problem size big enough? B, is the problem itself parallelizable? Does it make sense to? And C, does it make sense in this particular context? Going back to an example of a Java 8 course I was teaching recently, I gave them a problem to work with streams, but two of the guys in the class who were done, but were very eager, converted that stream to a parallel stream, and then they called me and said, "We want you to take a look at it." Their code, was at a certain performance. Turning into parallel, in this case, actually gave a lot slower performance. And the reason was this was a very relatively small problem size, and also the computation was relatively small. And the program took more time spinning the threads and closing the threads and dividing the work than the time needed to get the work done. So there was more overhead relatively than the work that was involved in this particular problem. And this was an eye-opening moment for them, because they said, oh, now we see why we can't blindly throw parallel into the code. We've got to be very careful about it. The second thing is, how many threads do you want to have for a problem? Well, that depends on two things. Is your computation, is your task computation intensive, or is your task I/O intensive? If my task is computation intensive, I shouldn't give any more threads than the number of cores. If my task is I/O intensive, I can throw as many threads on it as I want to. So the question really here is, we should understand the nature of the problem to know what makes sense and what doesn't make sense to use. And as much as these tools being available, we can't have a system that decides to apply these tools arbitrarily on our code. And for the systems to be able to analyze our situation and be able to use requires enormous amount of intelligence. And I'm not sure if the general purpose code we normally write gives an opportunity for that kind of mining of intelligence from them. Maybe there is a hope that that could happen, but the cost of doing that is so enormous, I think, anytime soon, that I think we shouldn't really even bother to expect something like that. These are beautiful tools in our hands, but it still requires human intelligence to decide when to and where to apply these tools.
I see. Do you think that maybe having some kind of profiling that could be connected to your app could actually decide on runtime if you'll use parallel streams or not, based on the behavior that some stream might be having?
Theoretically possible. Practically, I'm not convinced that something like that would be realistic, at least not with what we know so far, I think.
Okay. Okay, some other questions that we have here from our audience. We're almost out of time, but I think we still have time for a couple more. So this is a question from James O'Leary, and he's asking, what do you think about the lack of support for checked exceptions? There's some workarounds online. What do you think about the workarounds that people usually follow?
So this is, I'm assuming, with streams and lambdas.
Yeah.
One of the problems is this: we have a fundamental disconnect in our mind. If we come from an imperative world, most of us have developed code in imperative world. I spent my youth developing in imperative style, and all into my adulthood. I have the most experience with imperative compared to functional style programming. But when looking at functional style of programming, I look for the semantical difference between the two. In an imperative style of programming, you are calling a function, that function calls another function, and now you run ground. Your immediate reaction is, I'm going to go back and report that something went wrong, and then let the caller of my function deal with it. Well, that makes sense when you are in this imperative style of function calls and return from function calls. With functional style, one of the most important things, well, two of the most important things are function composition and lazy evaluation. With function composition, this is like the word stream itself, indicative of this. You're starting, it's like a mountain, and you have water flowing downstream. And when you're downstream, when something happens, it's too late for you to go back upstream. And you have to really go downstream further and deal with it down there. And it's kind of like, you know, when I'm in an airplane, because I traveled so much, I do this. I leave stuff in an airplane, like my iPhone, whatever. And I come out of the airplane, I can't run back. That's the easiest way to get arrested, especially in today's world of you know, security and all the hoopla, rightfully so, related to it. So what do? I literally go out to the baggage claim, and I'm waiting there hoping that I get the phone. And there are times I do, and there are times that's a good opportunity to upgrade to the next phone. But the point really is, you can't go upstream. You're done. You can only say something is wrong, and you can wait for a response to arrive where you are. And we have to change our mental model when it comes to programming with functional style. So this is where I was talking about the either would be a nice thing to have earlier on. And if you look at functional programming languages that from the ground up support functional style, they don't deal with exceptions like the way we do in imperative style languages like Java. So we have a disconnect on our hand. We have one style, and we are trying to bring the other style. And now we are trying to say, how do I deal with what I'm used to in this world, in this particular, you know, way of operating? And that doesn't really make much sense when it comes to dealing with it in that context. And I think that is something for us to think about. So we need to it's a design concern. It's not a concern of the library or the API. It's a concern of a design. We need to design our system in a way we can flow through the streams and deal with the issue further down. And we need to experiment and play with a few options and see how can an exception be a data. One example I'll give for you is look at reactive programming libraries. Like if you look at RxJava, for example, they don't throw an exception on you. What they do instead is you got a data channel and you have an error channel. Through the data channel, you keep getting the data, and through the error channel, you get the error. And you are dealing with data and the error downstream. And that's a good inspiration to draw from. Because when you have a service that's is sending you streams of data, potentially lazy evaluation, you can't say something went wrong, I'm going to go back up and handle it. You have to go down and handle it. And the way you could handle it is you can say, oh, I tasted this, what came from the service. It's not a data. This smells funny. It's an error. I'm going to dispatch into a secondary service to deal with it. Or, you know, rather than taking a right turn and going this way because I got a good data, downstream I'm going to take a left turn and go with that. Another place to draw inspiration is the promises API in JavaScript. If you look at the promises API, you have a then and a catch. And if the promise resolved properly, you follow through the then path. If the promise failed, you follow the catch path. These libraries are inspiration for us to learn from because they show a way to handle the scenario in a stream-based API that we're not used to when programming in imperative style. So rather than asking how the library can change for us, the question really we should ask is, how can we change to adapt to this paradigm? Because we need to learn to live in this paradigm rather than trying to change the paradigm to our need, because the paradigm has been built with a particular style for a reason, and it's our lack of understanding that hurts the most. And I've gone through the same pain as anybody else has. It was frustrating for me to say, oh my gosh, how do I deal with this exception? How do I throw it? And I went looking for answers. And these things I mentioned were inspiring for me to learn from in how to really treat exceptions as data. And your error is another form of data, and you deal with it downstream rather than trying to throw up throw it up.
Yeah, that makes perfect sense. I guess that we are very, very out of time now. Thank you so much for your answers. I have only one last question for you, which hopefully will be easy for you to answer and quick. So this is kind of like a joke question from Simon. He's asking if he should vote Brexit or not.
Issue what?
Brexit, Britain exit. Are you familiar with that?
Return exit, you're saying?
Britain exit from your European Union.
Oh, now I get it. You know what? That's Simon's problem.
Brexit.
That's not my problem. That's Simon's problem.
Okay.
I am not going to make the mistake that Obama did. I'm going to stay out of politics. I've got enough, controversies already in programming. So let Simon deal with it.
Okay. I'll let him know.
Or he can ask Obama.
Yeah.
I mean, we elected him for a reason, so let's ask him.
Well, he's going to get and have time to answer that. But maybe we can have him next time here on the Book Reading Club as well. Maybe he has got some time free after he leaves White House.
Hey, thanks for having me.
This is like a little joke. So we are pretty much out of time, guys. Thank you so much for watching this Book Reading Club with Venkat. We actually didn't have we didn't go through the book a lot because we have so many questions from our audience. So thank you so much for bringing all these interesting questions for Venkat, and of course thank you Venkat for being here with us and taking his time to enlightening us with all his knowledge and us answering all these awesome questions. We're gonna have another session in a few weeks. Actually, can't remember the date. Let me see it right here on my calendar. Oh, it's 11 May. The meetup is not created yet, but I'll create one soon. So please have a look into that and sign yourself up for the next meetup. And we're pretty much done here. So thank you so much, guys, and see you next time.
Thank you, Venkat, and thanks the audience for the questions.
Thank you.
Okay, bye-bye, guys.
Bye-bye.